heard of if you've never heard of sustainable software engineering, it's an emerging discipline at the intersection of climate science, software, hardware, electricity markets, and data center design. Sustainable software engineering is an emerging discipline that deserves a closer look. And here to talk through the 8 principles of sustainable software engineering is our colleague and my friend, Chris Adams. Welcome, Chris.
Hi, Asim. Nice to be here. Thank you.
Nice to see you again, mate. So I think we've known each other for about two years now, and in fact, when I first woke up to the climate crisis that we're in right now, one of the things that was sent to me was to go join a community called CAT, ClimateAction.tech, and that's where we met, and that's where we're co-organizers of. Why don't you tell people what CAT is?
Yeah, okay. ClimateAction.tech is a professional community for people who work in tech, like you and me, and hopefully other people on this group who are concerned about the climate crisis. We have a clear mission, which is to make climate action at work by tech professionals more effective. And generally speaking, what we are a kind of multi-organizational group where if you work in this industry and you want to see more action, you have a chance to find other people who are like-minded so that you can work out how to apply these principles in work, but also how to make the arguments to basically bring more of yourself to work. So you can actually think a bit about where the levers might be so that we can come up with something of a response that's in proportion to the scale of the challenge that's facing us when we think about climate. And that's largely what we've doing. I wasn't actually the founder. I found out about this from a group of people who are running this in America. And I thought, I live in Europe. This sounds really, really cool. I don't want to fly to America. Maybe I can just get in touch with these people. There's a guy, and as a result, we ended up joining calls, organizing things regularly. And now we advise people working in public sector and in private sector, and we organize unconferences and events, and that's partly where I met Asim in person for the first time, I think last year actually.
Last year. Now we're both organizers or co-organizers of Climate Action Tech. But what else do you do? What other work do you do in life? I suppose.
So Climate Action Tech isn't the only thing that I do. I work as a director of the Green Web Foundation. You can probably guess what the Green Web Foundation might be. And we basically work towards doing everything we can to make the web green, which largely revolves around making it run on renewable energy. I also run a consultancy called Greening.digital, which basically helps digital teams work out how to assess and improve the environmental performance of their own services, because we're in a climate emergency, and this is a kind of very important thing for us to be working on. And I think those are the 3 things that take up the majority of my time. I do a bit of advisory work with a number of other kind of startups and other companies, but those things keep me plenty busy, to be honest. Climate Action Tech is quite an active community, and it's quite a lot to keep up with there.
Yeah, it's quite a lot of work being an organizer of that community, definitely. So the thing we're here to talk about today is one of the things that we've spoken a lot about over the last year, and we speak almost every time we have a conversation. This is what we talk about, and it's really, we're trying to figure out ways in which developers can have a meaningful impact, or engineers, I should say, can have a meaningful impact in their work, in their industry, and help learn how to build applications in a more sustainable way. And one of the things that we've been working on together is this thing called the Principles of Sustainable Software Engineering. And what I wanted to do today was kind of have a bit of a Q&A and a quiz with you, where we talk through some of those principles. And in fact, if you go to principles.green, you can find the work that we've done. We've kind of listed out the principles, the 8 principles. I don't know if you have the time for the full 8 principles today, but we can certainly make a good stab at it. But I think the first principle that we have, also I should probably give the definition of sustainable software engineering. I think I might have already given it, but it's an emerging discipline at the intersection of climate science, software, hardware, electricity markets, and data center design. So it's kind of this union of a whole bunch of different disciplines. But what I say is that if you can just get like a good grasp of this breadth of knowledge, doors start opening up to you about understanding ways you can be a lot more sustainable in your work. And that's where the principles come from. And the first principle is carbon. Like, what is carbon, Chris? Like, why do we even talk about it?
Why do we mention carbon as a principle? Because, well, we're in a climate emergency and there's too much carbon in the atmosphere. And this is one of the key things that we need to, like, I'm just going to give you the very, very quick kind of climate science thing. We basically, over the last, say, like 200 years or so, we've seen lots of progress by taking lots of carbon that's in the ground and putting it in the atmosphere where we are. And there's now too much, which we're now seeing in the form of various kinds of climate change related effects. Now, the thing is, everything we do, almost everything we do uses energy. And historically, that's come from basically taking this carbon, which is underground, and burning it. And that's brought lots of good things. But we are now in this situation where if we want to kind of continue, we basically want to find ways of doing the things we do enjoy, like having access to the internet and everything like that, but do it in a way without emitting quite so much carbon. And this is what the science is pretty much spelling out to us. It's like, we need to stop emitting so much carbon. We need to find ways of getting it out of the atmosphere. So the thing we're going to focus on here is basically how to do the things that we have traditionally been doing as professionals, but in a way which is much, much more carbon efficient. So we don't have this unfortunate side effect of, well, basically working and building the services that we do.
That's exactly it. I think it's about, as you say, it's about being carbon efficient. I always say, like, it's very, very hard in life these days, very, very hard to live it without emitting carbon in some way or another. So the goal and our challenge is to make sure that for every single gram of carbon that is emitted, we are getting the maximum value out of that. And that's kind of why I would say that's the first principle of sustainable software engineering is when you're questioning what you should be doing, your choice should be whatever is the most carbon efficient choice. Which leads, I think, to the second principle, which is about electricity. I'm now an energy nerd. I know you're an energy nerd, electricity nerd, I should say. And the principle, I think, is build applications that are energy efficient. Like, why is electricity even mentioned?
Well, I think the reason we talk about electricity, because while carbon might seem a little bit abstract, we do have it's basically the main source of carbon from IT is basically our use of electricity. And there are two levers we might have. One option is to make sure energy is greener. And you can see some of the steps that have been taken by large organizations like Microsoft, who now actually do run a significant or almost all of their power from green sources, or take steps to offset this. And the other option is to basically use less energy in total. And to kind of give you some idea, in many cases, this is basically making better use of the power, just like Asim just said. And when we think about it, the industry average for, say, utilization of servers, most of our servers are idling. So we look at figures like, say, maybe 14 to 15% utilization is quite common for the infrastructure we run. Now, that's like buying 7 servers and only using one of them and still just basically having the other 6 doing nothing. Now, this is one of the kind of promises of the cloud, is that because you have a cloud in one place and you have a number of different users, you can kind of smooth out some of the kind of peaks of individual use. So it ends up being a much more efficient utilization of this same energy. So you get more value from the same energy used. And because of this, we've basically seen a massive increase of compute usage over the last 5 to 10 years without that much of an increase in total energy usage. So that's a good thing. But we just need more of that, really.
Yeah. And I think we're just bringing it back. Is when we talk about electricity, when we think of electricity, we don't think of it as dirty. And I think that's really fascinating. Like, we think of it as clean. Like, we plug something into a wall socket. There's no oil coming out. There's no dust. There's no chalk. There's no nothing. It's clean. It's coming through. Our hands don't get dirty. But it's actually one of the dirtiest things on the planet. I think one of the stats I use is 49% of all the carbon emissions in the world are actually from the production of electricity, which, I mean, when I first saw that statistic, it really slapped me in the face a little bit, but it also gave me hope as well, because you think, well, hang on, I know electricity. There's things I can do with electricity. I can be more efficient with electricity. And I think that's one of the things I would say, like, so the first thing, if you're building applications, if you're stuck with trying to decide what to do, then always choose the option that's the more carbon efficient. Then always choose the option that is the most energy efficient as well, because if you can be more energy efficient with electricity, then you're emitting less carbon to create that electricity. And bringing that carbon back to the topic again, there's another fascinating topic, and I think you and me could probably talk for like 4 or 5 hours, a whole day, on just the topic of carbon intensity. I think that's why we've got that as the third principle in the principles, which is consume electricity with the lowest carbon intensity. What is carbon intensity, and why is that important?
Carbon intensity. Okay, I'll talk a bit about this. So, as we mentioned before, you can get energy from a number of different sources, and some forms are going to be much dirtier than others. They're going to have much more carbon emitted for the same amount of energy. So, for example, if you're burning lots and lots of coal, that's going to be have much higher carbon intensity than something like, say, solar panels or wind turbines or anything like that. So you have one kind of choice there. But there is it's also worth bearing in mind that in many cases when we have a grid, there's an energy mix. So there'll be different levers that you have there. So yeah, you can say, I want to be using green energy. But in many ways, if you do not have access to that, for example, the amount of the carbon intensity of the grid will change depending on where you are in the world and what time you are using that electricity. So a good example might just be, say, at night, you're going to have a different carbon intensity because you're not going to have the same degree of solar, for example. But you'll have some people who are trying to kind of balance the grid to basically make sure that all of the people generating power to go into it that we can use is in demand, is in balance with the demand that we have. And in many cases, you'll see that when there's lots and lots of demand on the grid, you'll end up having a high price. And in many cases, you'll often see, say, high-priced, high-carbon electricity basically being fed into the grid. So if you can find ways to avoid needing power at the peak, then you'll often pay less, but you'll often end up using greener power. And this goes to such an extent that there are certain times where you can end up with negative energy prices, largely because the grid there is too much energy being generated, and the people who run the energy grid, they're trying to find ways to basically get people to help balance it in the same way that we're used to balancing, to kind of create this balance. And this is something we can take advantage of as developers. If we can shift demand to run in greener places or run at different times, then we can end up with maybe cheaper services to run in the long run. And there's a load of really fascinating work. But I'm going to hand it back to Asim before I nerd out too much about that, because it's quite exciting, and there's a load of good examples we can point to now. But Asim, I'll hand over to you before I jump into that.
Yeah, no, definitely. So I think, it's definitely one of the topics that fascinates me the most. And just to kind of summarize in a different way, so there's a number basically called carbon intensity, which is the grams per kilowatt hour, which is the measure, I should say, of kind of how dirty electricity is. And as you said, in different regions, because that region may have a lot more coal or gas or something else, the carbon intensity might be higher. In other regions, it might be less. In different times, which is the most interesting side of the thing, as the demand ebbs and flows, as the wind increases and the solar increases, you can get greener energy with less carbon intensity. And just without change, it's the beautiful thing about this, without changing any line of code, nothing, just by making the decision regarding when or where you run your workload, you can actually build applications that emit less carbon. And I think that that's why I'm so interested and excited about carbon intensity as well. And that's kind of what gives me goosebumps about it all also. Did you want to mention some specific examples there, Chris? I think we've got some time here.
So there's actually, if you work with Kubernetes, there are some really nerdy but also really fascinating papers. There's a group who released a paper called a low carbon Kubernetes scheduler last year, and what they basically did was they basically built an extension to Kubernetes so that knew when electricity was green and cheap. And they ended up using, I think they used a number of different clouds. I think this particular example was using Microsoft's clouds. And they basically used this information to work out where to send work depending on where energy was cheap and was green. And they could build this into the into Kubernetes, the way Kubernetes was actually running. And this has you now see companies that are actually acting upon this. So there's a company called Helio.exchange who now basically allow you to kind of take part in this process. What they actually do is if you run anything like, say, Kubernetes or different kinds of infrastructure, they found ways to allow you to kind of sell compute power back into like the kind of grid, as it were, in the same way that people might get a feed-in tariff or be paid for generating for generating power and selling it to the grid. They're doing the same thing for computing. I think they're a really interesting company, and they're building this on a load of open source tooling. You'll also see this in a number of large companies now that are starting to do this because it's becoming more accessible. And when you think about how, say, spot markets and things work in things like cloud, you can see so many parallels with how basically we price and use energy around. And in many ways, there are so many parallels here. Like in Europe, for example, one of the reasons we have a relatively green grid is because when there is a surplus of energy in one place, they can sell it to another country's grid. In the same way that we might, say, have the internet, which is comprised of a number of different networks, we have the same thing taking place. And there is also work to do something like this in America, to have this kind of internet of power, as it were, for this. So there's, seriously, if you have any kind of understanding of the internet, you will see so many parallels, and there's so much kind of interesting stuff here. I really, really love it. And this is the thing that me and Asim are a bit, it's basically our favorite thing to talk about right now.
I try to kind of, it is really fascinating, and it's kind of this. It's amazing because I see it as this world behind the real world of this incredible complexity. We've actually got some really interesting questions coming through from the audience. I thought I could ask you some of those. So one of them from John is, how can web developers contribute to this being, I presume, the sustainable software engineering? Oh, and become part of sustainable software engineering. So there is I can give a few pointers. So there is actually a kind of small but growing community talking about this a lot. There's actually a W3C, Sustainable Web Design interest group. There is also, if you look up the Sustainable Web Manifesto, there is actually a manifesto you can see and sign. There is also there is a number of books where you can learn about this now, actually. And there is a book by Tim Frick called Design for Sustainability. It came out a few years ago, but I do know there's another book that's coming out from the author of Whole Grain Digital, who's also been working in the founder of Whole Grain Digital web services company. Generally, I think, and this is why we spend a bunch of time in kind of climateaction.tech, is to find people who are working in this field, because you are seeing people are waking up to the fact that if you work as a developer, pretty much most of the tools you use to make your websites faster and more accessible also have a nice effect of making them greener, because a more accessible website is a website that can be used by older devices so that you don't need to upgrade so much. But also websites, if we bear in mind the fact that basically sending data uses energy, and energy comes from burning fossil fuels. In many cases, if you are able to reduce the amount of data that you send over the wire, not only do you end up with a better user experience and a faster website, but you also end up with a greener website. There's some work I've been doing with the Green Web Foundation and SiteSpeed, where we've basically taken some web performance tooling like this and made it possible for you to work out the carbon footprint of a website. So you can optimize that. And tools like, say, webhint.io from Microsoft, you can totally see how you do similar things with this as well. So I'd say check your website against the Green Web Foundation, see the dependencies that you have, check the tools that you have at a kind of web developer level, and essentially things that you can measure and reduce and work faster will usually result in a greener website. And this also applies on the server side as well. Yeah, great advice, Chris. And I think also they could also go to principles.green as well and kind of check us out and see the work we're doing there. And while we're on the topic, what we're trying to do is we're trying to grow this entire field of sustainable software engineering. We're actually trying to figure this out. So just before we head off, we've actually started a podcast. We can go to podcast.principles.green, and you can check us out on our journey as we grow the field of sustainable software engineering. Thank you so much, Chris, for your time today. Thank you so much.
Cheers. Thank you.
After the break, we'll be building a web for everyone. Stay tuned.